Okay, so let's start. My name is Ajay Jacob. I am the Director of Projects at the California Dreams Hub. It's my pleasure to invite Professor Peter Westwick. He's a professor of the practice in History and Thematic Option at the University of Southern California. He received his BA in Physics and PhD in History from UC Berkeley. He's the author of Into the Black, JPL, and the American Space Program in 1976 to 2004, which won book prize from the American Institute of Aeronautics and Astronautics and the American Astronautical Society, and the National Labs Science in an American System, that is from 1947 to 1974, which won the book prize of the Forum for the History of Science in America. He is also editor of Blue Sky Metropolis, the Aerospace Century in Southern California, and co-author with Peter Neushul of The World in the Curl, an Unconventional History of Surfing. His latest book is Stealth, The Secret Contest to Invent Invisible Aircraft. He is currently writing a history of high-tech industries in California since the gold rush. So it's my pleasure to invite Professor Peter Westwick to give the talk, The Entangled Histories of Aerospace, Electronics and Computing in Silicon Valley and Southern California. And this talk is going to be quite different from what you have so far listened to. It's in history, and it's going to be an impromptu talk rather than with slides. Peter, the stage is yours.
Thank you, Ajay, for the generous introduction, and thank you all for having me. And many of you probably know more about this topic than I do. So hopefully I can shed some light on some interesting connections and themes and maybe bring up some new angles for you all. And I'll try to leave plenty of time for questions also at the end. And as Ajay mentioned, I'm sorry I don't have any slides prepared for this. This is very much a work in progress. In fact, I'm writing, some of this is based on a chapter that I'm right in the middle of writing. So it's very fresh research, but it will be kind of not quite off the top of my head, but a little bit more hand waving perhaps than I'm usually used to giving. So anyway, bear with me, but hopefully there is some interesting history for you all in the talk here. So it's common for a region to become identified with a particular industry like Silicon Valley. And, think of Detroit and automobiles or Switzerland and watches. But California has been exceptional in being the world leader at different times of not one or two, but several major industries. So, mining with the gold rush, oil, agriculture, aerospace, of course, Hollywood, biotech, and electronics and computing, what we think of as Silicon Valley. So it would take a whole book to explain how this happened, and that is, in fact, my current research project. So here in this talk, I will focus on the origins of Silicon Valley and also on the connections between aerospace on the one hand and electronics and computing on the other. It's a long story. It goes all the way back to the gold rush, which was what we would call today a knowledge economy. That is an industry based on advanced science and engineering expertise. Hydraulic mining in particular taught California engineers how to handle huge volumes of water at high pressures, and they soon turned this expertise into generating electricity. The problem was that the water for the hydropower was in the Sierras, and the demand for the electricity was in the cities hundreds of miles away. So what that required was transmission lines over these long distances. These transmission lines operated at very high voltages to avoid losses due to resistive heating. But the problem was that at such voltages, the transmission lines, the insulators on the lines broke down, and the power lines tended to arc. So California turned to electrical engineers to solve this problem. By 1914, power lines at hundreds of thousands of volts were running from the Sierras down to the Bay Area and also to Los Angeles. California at the time had more long-distance power lines, more long-distance high-voltage lines than anywhere in the world. And to enable these achievements, UC Berkeley, University of California, Berkeley was the only campus at that point, so University of California, Stanford, and what would become Caltech all built world-class programs in electrical engineering going back to the 1890s. Their faculty consulted regularly for power companies, their labs performed research for utilities, and their graduates went on to work for electric companies. And these California electrical engineers over time made the jump from macro to micro scales. It started with early radio systems, which used spark gap transmitters, which were not so far removed from the research underway on arcing across voltage gaps. Federal Telegraph Company, which pioneered long-distance radio transmission, was formed in Palo Alto in 1909 by a recent Stanford grad, with financing from Stanford's president and also other Stanford engineering faculty. So Federal prospered from Navy contracts in World War I, which provided both funding and ambitious requirements that drove technological advances. Federal also hired an engineer by the name of Lee DeForest, whose name might be familiar to some of you. He invented a vacuum tube amplifier, which is really a major technological step and kind of the next technological frontier for radio transmission. So what you had then was in the 1920s and 1930s, kind of a resonant circuit for engineers working in vacuum tube electronics in this electronics industry in the Bay Area. So, for example, Federal hired a young intern by the name of Frederick Terman, whose name might also be familiar. 25 years later, as Stanford's Dean of Engineering, he would earn the title of the father of Silicon Valley. But when you look at this longer history, it becomes clear that Frederick Terman was as much a child of the Bay Area electronics industry as he was its father. Federal also hired another Stanford grad by the name of Charles Litton, who went on to found Litton Industries, and also funded a scholarship at Stanford, one of whose early recipients was a young student named David Packard, who soon went on to co-found Hewlett-Packard. Two other Berkeley and Stanford grads, meanwhile, founded a firm called Heinz and Kaufman in San Francisco, another major electronics firm at the time. And Heinz and Kaufman collaborated with both Federal and Litton, and then two of its staff then spun off their own firm, Itel McCulloch, better known as iMac, which would later be bought out by Litton. So completing this circuit back in the 1920s really was the kind of focus of this. And these early firms, by the way, relied not only on the electrical engineering programs at Berkeley and Stanford, but also on Berkeley's chemistry and chemical engineering departments, especially for the process engineering for the materials of the elements of these early radio tubes. So the line in Bay Area electronics then continued through World War II, firms like the Varian brothers and radar technology, and then on to the post-war microelectronics of Shockley, Fairchild, and their successors. And this is kind of the more familiar history, and most kind of standard histories of Silicon Valley really pick up the story here with World War II and then the early Cold War with the transistor and then integrated circuits. But this earlier history kind of really shows us that the Bay Area was home to a thriving electronics industry decades earlier. A local journal in 1921 counted 30 local electronics firms with thousands of workers. And this early industry is interesting also because it defines several of the patterns that would then recur later in Silicon Valley. So blurred boundaries between industrial firms and local universities, intersections among the firms themselves with these kind of peripatetic engineers spreading knowledge among the firms, kind of like honeybees pollinating a meadow. Amateur hobbyists were another prime characteristic of this early radio industry. And the amateurs, but also eventually going on and acquiring advanced engineering expertise, going to Berkeley and Stanford, and then going out and going into the radio business. This would also, of course, recur later on in the 1970s with some computer enthusiasts. Patent lawyers specializing in intellectual property for electronics. This was also a feature of the 1920s. The local capital enabling firm creation and firm growth. And last but not least, military interest and military funding providing a crucial impetus. And this last point brings us to another of our topics here, which is the connections between aerospace and Silicon Valley. The Bay Area electronics industry from the outset was essentially a creation of the US military, going back to radio electronics in World War I, and then onto radar in World War II, and then microelectronics in the Cold War. Go down the list. Federal Telegraph, iMac, Hewlett-Packard, Litton, Varian, all of them were sustained in their crucial early years by government contracts, probably would not have survived without government contracts. And for that reason, one historian has called the US military the biggest angel investor of them all in Silicon Valley. And integrated circuits perpetuated this pattern. Funding from the Air Force and NASA drove the miniaturization, reduced cost, and increased reliability of integrated circuits, especially for the guidance systems of the Minuteman missile and the Apollo program. And this federal subsidy is basically what enabled semiconductor firms to figure out how to reduce the size and the cost of circuits basically like 1,000 times. And only then, once they've achieved that reduction in size and cost, were integrated circuits accessible to consumer electronics. And that military role persisted. This is back in like late 1950s, early 1960s, but that military role persisted. If you go forward into the 1980s, Santa Clara County was receiving about $5 billion annually in defense contracts, which is the third most among all American counties. And then, of course, you have digital electronic computers and the internet, both developed by and for the U.S. military. Most of the components of smartphones were the result of federally funded R&D, and the seemingly recent emergence of artificial intelligence also dates back to funding of military funding of AI, going back to the 1960s, actually probably even earlier than that, but Stanford being an special kind of epicenter for that military interest in AI going back to the 60s. And there were specific connections here with the aerospace industry. Before Santa Clara County was known as Silicon Valley, it was actually Aerospace Valley. It wasn't really known as Aerospace Valley, but one could have called it that. In 1956, Lockheed set up a major missiles and space facility in Sunnyvale, Lockheed Missiles and Space, which is right next to the major NACA, then NASA Center at Ames. Also nearby, you had Philco Ford in Palo Alto, a major NASA and Air Force contractor. Lockheed Missiles and Space won a major Navy contract for the Polaris submarine missile, followed by Air Force contracts for the Corona spy satellites in the early 60s. And Lockheed in Sunnyvale was the largest employer in Santa Clara Valley through the 1960s and into the 1970s. One of those Lockheed employees, by the way, was an engineer named Jerry Wozniak, who delighted in teaching his son how to play with electronics. His son, of course, being Steve Wozniak, whose name might be familiar to some of you. Another angle here, another connection. Missiles and satellites required systems to survive in zero gravity, which meant eliminating dust and contaminants from the manufacturing process. Particles, for instance, that might float around in outer space and short out electronics or settle on the film of a spy camera. So a series of failures on the Corona satellites in particular led Lockheed to basically tighten up its quality control. And in the process, Lockheed mastered the art of building clean rooms. And in the process, it taught local HVAC contractors in the Southern Bay Area basically how to design and install sophisticated filtration systems. And that by learning how to do that for the aerospace business, it made these clean rooms then relatively accessible to the manufacturers of semiconductor chips who were hard on the heels of these developments in aerospace. So the clean rooms kind of went from aerospace then into semiconductor manufacturing, and then also, by the way, on into biotech. So there's a basic question here, why is Silicon Valley in Silicon Valley? Why is this electronics and computing enterprise focused so heavily on the Bay Area and specifically on the Santa Clara Valley? The answer is often sought in World War II era Stanford. Frederick Terman builds industrial parks next to Stanford and basically helps to catalyze this industry. And then there's a subsequent influence of Bay Area counterculture, which some historians posit played a role. But in fact, I think we need to look back further, much further, even eventually to the gold rush, which then spawned hydropower, which then spawned electrical engineering programs, which then fed into this radio electronics enterprise. So by the time Silicon Valley acquired its name in 1971, Bay Area engineers had, for close to a century, been developing the technologies, the infrastructure, the institutions that then enabled the electronics and computing industries. So you need to look deeper. We'd also need to look more broadly. not just at electronics itself, but looking at other canonical California enterprises, such as hydropower, but also especially aerospace, um, that helped to catalyze Silicon Valley. So many other places have tried to replicate Silicon Valley more recently, but it is not so simple as just plopping down an industrial research park next to a university. And this history shows that Silicon Valley was the product of this very rich ecosystem that is much harder to duplicate, as all of these other efforts, to create Silicon Fen or Silicon Taiga or Silicon Wadi or going to Silicon Hills. None of them have managed to really duplicate Silicon Valley. And I think the reason is because of this ecosystem that Silicon Valley came out of. Okay. That's the Bay Area part. What about Southern California, you might ask? And yes, microelectronics were not just a Bay Area phenomenon. Southern California also boasted substantial enterprises in electronics and computing, as I think many of you can probably attest. As with Silicon Valley, the roots of SoCal electronics go back to the early 20th century and also display connections with other local industries, including aviation and Hollywood in this case. So it goes back to 1912, at least as far as I can tell. In 1912, two brothers, one of them was a new Stanford grad, they bought out an uncle's foundry in Los Angeles, the Gilfillan brothers. So the Gilfillan brothers firm first specialized in making platinum points, kind of rare metals, platinum points, especially for car ignition systems. And then during World War I, they shifted into aviation and building parts for aircraft. And then after the war, they got into radio electronics. They won the West Coast license to build RCA systems in the 1920s. And then in World War II, got more into radar. They won a big contract to build a ground control radar for the MIT Rad Lab to help airplanes land in bad weather. And that was the aviation connection. The Hollywood connection came through their chief engineer, a guy by the name of Homer Tasker, who was previously the sound engineer for Universal Studios and Paramount Pictures, and in fact had earned 2 Oscar nominations for sound. And I'm not going to get into the Hollywood connection here in this talk, but there's an interesting connection actually between Hollywood sound engineers and submarine warfare, which I won't go into here, but it's a pretty interesting little side story. Anyway, back to Gilfillan. So Gilfillan built dozens of radar sets during the war for the U.S. military. And then after, well, let's see, by 1948, their systems were in use at over 100 Air Force and Navy airfields, and also at civilian airports in New York, Chicago, Washington, D.C., and other airports. By that time, the firm had 1,000 workers at a thriving factory on Venice Boulevard. Continued as a major firm into the 1950s and into the 60s. And in 1964, it was bought out by ITT, which just happens to be the same firm that bought out Federal Telegraph back in 1928. So there's all these connections. When you start trying to trace the connections in people and firms, you end up with just this dizzying network on your page. So in the early Cold War, back to the aerospace connection, in the early Cold War, aerospace firms across the Southland ventured into electronics for missile guidance, for space communication especially. Hughes Aircraft early shifted from building airplanes to building electronic systems, such as traveling wave tubes to replace the old klystrons and magnetrons that were used to generate radar. Among other things, these traveling wave tubes enabled the CENTCOM communication satellites that, among other things, they beamed the TV signals from the 1964 Olympic Games in Tokyo to the United States. By that time, Hughes had a semiconductor fab in Newport Beach, making integrated circuits to meet special military requirements, such as radiation hardening, to allow electronics to survive in nuclear environments. Lytton, meanwhile, had relocated to LA from the Bay Area after a former Hughes employee by the name of Tex Thornton bought out Lytton's tube business in 1953. The year after that, the director of semiconductor research at Hughes, along with a few other Hughes staff, left Hughes to form a firm called Pacific Semiconductors in Culver City, making diodes, high power, high frequency transistors, Pacific Semi was acquired a few years later by another local aerospace firm with an interest in electronics, TRW. Um, Most TRW also, like Hughes, building uh, electronic systems for missile guidance and also for space communication. TRW researchers in the early 1960s developed what was called transistor logic, TTL, which became a standard basis for integrated circuit design. The firm also operated a semiconductor fab at Space Park in Redondo Beach. Orange County was a particular hub for microelectronics. Aeronautics, it was the electronics division of North American Aviation, later on North American Rockwell. Aeronautics by the 1960s had 36,000 employees at a 240-acre site in Anaheim. They're making metal oxide semiconductors and other integrated circuits. Aeronautics later spun off several major telecom firms in the area, Connexent, Mindspeed, Skyworks, among others. Another electronics offshoot of aerospace, this one was called Aeronutronic. It was an offshoot of Lockheed's missile division. And then Ford bought them in 1956, but Aeronutronic had its own 200-acre site in Newport Beach. And nearby Western Digital had a chip fab in Costa Mesa. So chip fabs kind of spreading across the Southland, a lot of orange groves being converted into chip fabs going back to the 1950s and 1960s. These electronics programs, like their Bay Area counterparts, cultivated connections or cultivated and also depended on connections with local universities. In this case, Caltech, which like Berkeley and Stanford, had early on built a strong program in electrical engineering for hydropower transmission, and then got into radio electronics. After World War II, Caltech developed close ties with local aerospace firms with a kind of orientation towards electronics. TRW hired a whole lot of Caltech grads, also sent its employees to Caltech for graduate degrees. Hughes supported a fellowship program at Caltech, also had a work-study program for its technical staff that would pay for graduate coursework at UCLA and USC. And of course, as many of us might know, the engineering building at Hughes is the Hughes Engineering Building. And it's the Hughes Engineering Building for a reason. Now, over 4 decades, more than 4,000 Hughes scientists and engineers received graduate degrees under this work-study program. And after 65, Hughes also ran its own kind of in-house university with courses taught by its own senior technical staff or also by visiting professors. One of the visiting profs, the guest lecturers at the Hughes University, was a Caltech professor by the name of Richard Feynman, whose name might also be familiar to some of you. So Feynman was teaching courses at Hughes. Caltech and other California universities continued to make major contributions to semiconductor electronics. By the mid-70s, microprocessors were becoming so dense that design rules, for instance, specifying the distance between individual lines of a circuit on each layer of a chip, the design rules were getting too convoluted. So a report from Carvin Mead and Ivan Sutherland at Caltech and Tom Everhart at Berkeley launched a program called Very Large Scale Integration, VLSI. VLSI program simplified and standardized design protocols, also allowed chip layouts to remain consistent even as they scaled down. And the scalable protocols also then allowed the separation of design from fabrication, basically allowing semiconductor manufacturers to produce chips designed by other firms. This is what Carver Mead described as the silicon foundry model, which became really the prevailing paradigm in the industry. VLSI then led to a major DARPA project at Berkeley and Stanford, centered on Berkeley and Stanford, that produced major advances, among other things, an architecture called RISC for reduced instruction set computing, RISC architecture, the Unix operating system at Berkeley, Stanford University Network, or SUN, project for graphics workstations, which together with Unix eventually became Sun Microsystems. And yes, USC played a role in all of this. Of course, the Information Sciences Institute, ISI, created with DARPA funding in 1972, as a spinoff from the program at RAND, another aerospace think tank. 1981, ISI, as many of you probably know, launched a program called the Metal Oxide Semiconductor Implementation Service, MOSIS, which allowed faster and cheaper testing of chip prototypes by etching multiple chip designs on a single wafer, among its other many contributions. Let's see here, how doing on time? I might actually skip ahead here. I'm going to skip the Beckman Instruments story, Arnold Beckman, but it's an interesting story that connects Caltech with electronics and citrus, building a basically spectrophotometer for citrus lemon juice acid levels. Aerospace also helps develop smog. I'm going to skip that story in the interest of time. But the upshot is that by 1973, Beckman Instruments, another one of these Southern California electronics firms, was one of the 100 largest firms in California. Litton and Teledyne, both two SoCal-based aerospace conglomerates who made mostly electronics instead of airplanes and spacecraft. They're also high on that list. Bigger than Northrop, close in size to Lockheed and Rockwell, each far bigger than Hewlett-Packard, who is perhaps the more celebrated electronics firm in Northern California. By the 1970s, you had close to 1,000 electronics factories built in Southern California, almost twice as many as in the Bay Area. And their firms, Novatech, Megatech, Qualtron, kind of radiating this technological enthusiasm. By 1990, LA County had the largest concentration of electronics industry in the nation. So that's the electronics. On to computing. Like Silicon Valley, Southern California also developed a computing community. Early digital computers coming out of World War II were confined mostly to, or almost exclusively to, nuclear weapons design, cryptography, and ballistics calculations. This limited demand was not enough really to sustain a computing industry, and it was demand from aerospace firms for aircraft design, for flight controls, for missile guidance that really brought the digital computer into general commercial use, that created a commercial market for computers. Historians have identified Northrop in particular as what one historian called the midwife of the computer industry in the United States. This goes back to the late 40s when Northrop was developing both a long-range bomber based on the flying wing design and the Snark missile. The bomber required complex calculations of aerodynamics and structural loads. And Northrop engineers, to perform these calculations, kind of kludged together a couple of IBM devices, one a calculator and one kind of an accounting machine. They called their mashup after a firm, they called it the poor man's ENIAC, after another famous early digital computer. But Northrop engineers then persuaded IBM to basically introduce the next year after that, the Card Programmed Calculator, or CDC, based on their mashup. And the CDC, its innovation was that it could actually store programs on a deck of cards rather than having the programs hardwired into the computer through a plug board. And this stored program computing, of course, became the industry standard. The CDC was a mainstay in the aerospace industry, and many aerospace engineers cut their programming teeth on the CDC. Subsequent IBM model of 650 similarly benefited from collaboration with Lockheed engineers, who really showed IBM IBM engineers what the 650 could do. And IBM actually soon hired away the leader of Lockheed's group to help show and market the IBM 650, help show IBM engineers what these Lockheed folks were doing with the computer, then how they could help market it. And then IBM developed the next generation, the 701, another kind of landmark computer, still more advanced. Of the 19 701s built by IBM, 7 went to Southern California aerospace customers. And when IBM introduced an upgrade called the 704 a couple years later, SoCal aero firms were again a primary market. Northrop, meanwhile, was working on the Snark guidance system. 1949, Northrop engineers were trying to build a computer small enough to fit into a missile nose cone. They designed a computer, got Hewlett-Packard to build it, but it was still too big to fly. But it was so promising that they actually urged Jack Northrop, the head of the company, to go into making and selling computers as a business line. Jack Northrop declined, and that group then left Northrop to form a company called Computer Research Corporation, or CRC, which was just a couple years later acquired by National Cash Register, NCR. And that started NCR as really a major player in early computing. If you look at the lists of the major computer makers in the 1950s, NCR was really always close to the top of the list. And CRC out of Lockheed was kind of the path for NCR to become a major player in computing. And CRC itself then led to a bunch of other smaller, like maybe a dozen spinoff firms also. So similar to semiconductor circuits, so aerospace really provided kind of a crucial early market to get the computing industry off the ground. But aerospace also provided a community of expert users who shared tips and tricks among themselves. So RAND was an early center for computer science, as some of you may know. And the head of RAND's numerical analysis department in 1955, a guy by the name of Paul Armour, decides to create a users group for people who are involved in computing at various local aerospace firms. So he forms this group, they call it SHARE, S-H-A-R-E, and this kind of provided a really important early clearinghouse for computing in Southern California, sharing source code modifications, including an open source operating system for the IBM 709, which is another kind of canonical IBM model that was widespread in the aerospace business. Schur also led the creation of one of the first software companies in the country. Two young programmers, one at North American Aviation, the other one at United Aircraft, met at a Schur meeting, decided to create a firm and join forces, and they created a company called Computer Sciences Corporation. Sorry for all these acronyms. We've had CRC, we've had NCR, and now we have CSC. CSC got a major contract building software for JPL's mission control, and then basically spun off software packages for aerospace and then eventually other industries. Became the largest software company in the United States by 1963. Is, I think, the first software company listed on the American Stock Exchange, then went on to the New York Stock Exchange. Anyway, it came out of this users group. And you also had in Southern California by the mid-1970s what was called the Southern California Computer Society. So many of you may have known or have heard about this kind of celebrated club in Palo Alto in the Bay Area called the Homebrew Computer Club, which is where a lot of these kind of amateur computing hobbyists got together to share systems, share ideas. And of course, this is famously kind of the incubator for what became Apple Computer and Steve Jobs and Steve Wozniak and all that stuff. So the Homebrew Computer Club. Well, there was a counterpart in Southern California, this Southern California Computer Society, which was formed just a few months after Homebrew and quickly expanded to 8,000 members, far orders of magnitude bigger than the Homebrew Club. And most of those engineers were from local aerospace firms. The meetings were held at TRW. The Southern California Computer Society was probably too big and ambitious. It kind of developed this complicated bureaucracy, a board of directors, and of course the board of directors soon devolved into squabbling over the direction of the group. And the Orange County members spun off their own group, so it kind of eventually fragmented. But in the meantime, it was kind of an important nexus for computing in this area. So, given all of this computing and electronics activity in Southern California, why is all the talk about Silicon Valley in Northern California? Why doesn't the SoCal community get the same attention? Both regions had these early communities of electrical engineering expertise, sparked by hydropower and then expanding into radio electronics. The Bay Area community might have been bigger from the outset, basically because a lot of the early demand for radio was for shipping. And shipping, of course, San Francisco had a major port back in the 10s and 20s, and LA did not until the creation of what became the port complexes at LA and Long Beach decades later. Later on in the 1960s, another factor that some historians point to is the counterculture Basically, NorCal had hippies and Southern California didn't, according to this argument. And that it was this kind of the counterculture community in Northern California, which basically brought the personal computer into being by shifting the view of computers from these kind of big centralized mainframes to network individual devices, the kind of the personal computer. So your own personal computer, basically from computers as machines of kind of bureaucratic control to machines for personal creativity and social and political liberation, uh, as this argument goes. And so one might say that, okay, Southern California, it had a counterculture, but not as strong as Northern California. One reason this counterculture probably wasn't as strong down here is because you had this defense industry, right? And that, as a central part of Southern California culture and society, the security regimes of defense contractors did not exactly encourage transgressive activity. What might have been more important than that was just the fact that military secrecy really discouraged the kind of celebratory self-promotion that characterized Silicon Valley. And much of Southern California's electronics and computing industry, because of its association with aerospace and thus with the defense industry, it was very much anti-publicity. So it's kind of deliberately under the radar on these classified projects, which might be why we know relatively little about computing electronics in Southern California compared to Silicon Valley. All right, well, that's kind of been a brief whirlwind and again, kind of hand-waving survey of some of this history. And one could go on and one could talk about California's role in the telecom industry, which intersected all of this electronics in the Southland. You could talk about relational databases. You could talk about virtual reality. You could talk about computing graphics, video games, artificial intelligence, and so on. And by the way, also apropos the internet, you could also note that 3 of the 4 original nodes of the ARPANET, the basis for the internet, were based in California, UCLA, UCSB, and Stanford Research Institute. And you will all have probably noted that I've talked for close to 40 minutes now about electronics and computing in California without once mentioning Apple or Google or Anthropic or any of these more recent kind of iconic firms. But I really look at them as an effect and not as a cause of this industry and of these events that I've been discussing. Yes, they help explain why California is now the 4th largest economy in the world. It has passed Japan, I think. It has overtaken Japan last year. So it's now the 4th largest economy in the world if California was an independent state. But to understand why these industries are here in Southern California, I think you really have to go back and look at this deeper and broader history, to look, go back farther in time and also expand your view beyond just looking at these Silicon Valley firms and look at what was around them. And what was around them were these other California industries, hydropower, aerospace. You could also look at, Hollywood, and start looking at the connections among them to try to understand why California has these high-tech industries that it does today. So I'll wrap it up there to leave some time for questions, and I am happy to entertain questions that any of you might have.
Great. Thank you, Peter. Great talk. Any questions? Okay. It seems there are no questions. People have been listening.
You all are digesting all of this information that I've just
digesting all the information
spewed at you here.
Could you explain a little bit more about the Northrop evolution and also the RF evolution in the Southern California area?
I'm sorry, the Northrop and the what?
No,
other?
All the work that Southern California is particularly interesting with respect to all the deep fabs out there or deep companies out there, like Raytheon compared to the Northern California. Why would this be concentrating in the Southern California area?
Well, I think it's so. And I think that Northrop also has its own chip fab. I I think it's over in kind of El Segundo, maybe the El Segundo Redondo border, if I have it right. I think you can drive past it on what's the big north-south street. So anyway, Northrop, yeah, I think you could add them to this list of firms. So I think it really, it comes out of the aerospace and this interest in, electronics for aerospace, both for aircraft design, for missile guidance, eventually for space communication, um, and then later on for flight control systems. When you start getting computerized flight control, what's later known as kind of fly-by-wire systems. So aerospace firms have this keen interest in electronics, but they also have kind of specific requirements. They have to meet what is known as later becomes known as mil spec, the military specifications for electronics. So for instance, if you're designing a strategic bomber, it has to operate in a potentially post-nuclear environment, or satellites will have to operate in a post-nuclear environment, or guided missiles will have to operate in this environment, which means you need them to be radiation hardened, so they can sustain bombardment by all kinds of radiation, X radiation, neutron flux, single event upset, these kinds of things. And there is this kind of specialized electronics business to design electronics that can survive these sorts of radiation exposures that you don't need. Of course, you don't need your integrated circuit for a home personal computer to be able to survive in these kinds of environments. Hopefully, knock on wood. But the aerospace firms do. So they develop their own kind of specialized chip lines to make these special integrated circuits to these military specifications for these environments. So I think that's that's a substantial part of it. Just the military imposes these requirements that the aerospace firms are trying to meet, and they don't, Intel or AMD, at least early on, are not providing chips to this. Eventually they do, National Semiconductor, Advanced Micro Devices, Intel. Then later on, I think they do develop some chips that will make microprocessors that will meet the military requirements. But initially, the aerospace firms say like, well, we've got to do it ourselves, and that's where I think some of these what kind of motivates the construction of these very capital intensive chip fabs across the Southland.
Okay, thanks, Peter. There are two questions. One question is from Richelle Smith, and he's asking, could you share the side story on the connection of Hollywood sound engineers to submarine warfare you mentioned?
Right. So it's an interesting story, and there hasn't been really too much written about it. And I've just by kind of recognizing a couple of the names, I started kind of drawing these connections. But so, sound comes in famously in the 1920s into the film business. They figure out they're trying to figure out like how can we record and have the sound recording sync up with the film. And there's a whole history there. But basically the sound comes in and it really kind of revolutionizes Hollywood studios, because now they have to worry about acoustics. Before you had to worry about, the film recording and the lighting, but now you have to worry about the sound environment. And you've got to worry about, soundproofing, you've got to have your cameras, but also the entire sound stages. Now it's very sensitive to acoustics. And you get these sound engineers who come in with electrical engineering backgrounds. And they come in, they start looking at the studios and saying, okay, first of all, you need to, improve the acoustic environment, baffles on the walls, very sophisticated calculations for the placement of microphones. So we're going to have microphone here, microphone here, microphone here, some to capture the close-up conversations, some to capture the kind of ambient noise in a scene. You start filming outside, that's a whole other problem. But so kind of acoustical physics, acoustics is kind of this really almost like 18th century, 17th, 18th century field in physics, which kind of falls out of fashion by the 19th century. The 19th century, you get, electromagnetism, you get thermodynamics, and then of course you get the quantum revolution and relativity. And acoustics, it started to seem kind of old-fashioned, but Hollywood really brings Hollywood and also just the recording industry bring acoustics back in. So acoustical physics, universities start hiring physicists who specialize in acoustics, one of whom is a guy named Vern Knudsen at UCLA. There's also an interesting connection here with the Mormon Church. In the Mormons, there are a number of leading acoustical physicists who are Mormons. This is a very hand-waving explanation, but one theory at least is that, the Mormon Tabernacle Choir, the church is a very sophisticated acoustical environment. So the Mormons have, reacquired an interest in acoustics early on, and then that propagated into this field of acoustical physics. Anyway, these acoustical physicists then go starting to work for, Hollywood studios. So when the U.S. Navy, as World War II is looming again, and the U.S. Navy is getting back into sonar and underwater acoustics, they look to these acoustical physics, and a lot of them are people who are coming out of the Hollywood studios. So the upshot is, if you look at the two major submarine warfare labs in World War II and afterwards, one in San Diego and one in New London, Connecticut, the heads of those two labs are basically people who had previously been the sound engineers for Hollywood studios. So the U.S. Navy goes and says, we need specialists in acoustics. And they go and they pluck these engineers out of the Hollywood studios and put them into these underwater sound labs in San Diego and New London, which then became the basis for the Navy's ASW, anti-submarine warfare program, going into the Cold War, which is really a huge and really talk about under the radar, really highly classified, really not much is known about it, but a really vast effort by the U.S. Government, U.S. military into anti-submarine warfare in the Cold War, but with this really kind of intriguing connection back to Hollywood. So that's maybe either more than you wanted or less than you wanted, but that's an interesting story.
Thank you, Peter. There is another question from Gene Dansker. He's asking, if you have time, can you tell us the Arnold Beckman story?
Yeah, so Beckman is let's see if I can find my notes on this here. So Beckman is an interesting character. He had worked actually at Bell Labs on vacuum tubes. Yeah, well, it was the forerunner of Bell Labs, Western Electric, before it was known as Bell Labs. And then goes to Caltech and gets a PhD in chemistry. And this is in the early 1930s. And he then joins the Caltech chemistry faculty. But maintains an interest in electronics, and for instance, he is blowing glass tubes for the instruments for the Caltech chemistry, the instruments lab on campus, the instrument shop. So in the early 1930s, he's approached by Sunkist. So Sunkist, as many of you may recognize the name, is this local collective for citrus industry in Southern California. They collect the oranges from all the citrus growers and market them and sell them and package them and ship them on behalf of the farmers. So Sunkist wants help measuring the acidity of lemon juice. So one of the byproducts of, you get bad lemons or bad oranges, and the Sunkist says, like, well, we're not just going to waste those, we're going to turn those into lemon juice. The problem is the preservatives they added to lemon juice meant you couldn't test the acidity with this kind of standard litmus test. So they come to Beckman in the Caltech chemistry department and say, like, can you help us? So Beckman comes up with an electronic instrument. It's a spectrophotometer, kind of basically an electronic pH meter. And this is, again, the 1930s. And he says, you know what, I see a market for this. He quits Caltech, sets up a company called Beckman Instruments to basically produce these instruments. And then he sees this, more demand for other instruments, potentiometers, other kinds of spectrophotometers, and so on. So he's got this company in Pasadena in World War II. He starts acquiring military contracts for military electronics. In the Cold War, it expands even further. So this Beckman instruments are used by the Manhattan Project. They're used by MIT's Rad Lab for radar, and then grows further in the Cold War. There's also a connection here actually with Silicon Valley, in that Beckman had taught William Shockley, the co-inventor of the transistor. Shockley quits Bell Labs after inventing the transistor and comes back to the Bay Area. He's from Palo Alto, comes back to the Bay Area to form Shockley Semiconductor in 1955. When he does that, he approaches his old professor, Arnold Beckman, and says like, "Hey, can you help me?" And Beckman is on the board of Shockley Semiconductor, and actually Shockley Semiconductor is set up as a subsidiary of Beckman Instruments. So Shockley is this kind of canonical, really early electronics, you know, semiconductor for making transistors and then semiconductors in the Bay Area. And it's basically a subsidiary of Beckman. And then, of course, several staff of Shockley's firm, the so-called Traitorous Eight, they leave Shockley, go off and form, they're not happy with Shockley's management style. They go off and form Fairchild Semiconductor, and then Fairchild then, of course, spins off Intel and all kinds of other firms. But anyway, so Beckman Instruments becomes this eventually, one of the 100 biggest firms in Southern California. Beckman goes on and generously funds, research institutes at Caltech, Stanford, and a bunch of other places. So there's this kind of feedback loop then from Beckman. But and also in the process, Beckman also helps to discover. Beckman is, as a chemist, is serving on the LA. LA in the late 1940s, smog is becoming a problem. All of these cars and manufacturing industry in LA, and all of a sudden, there's this problem with smog. You can't even see the downtown skyline on smoggy days by the late 40s. They go to Beckman is a chemist. They approach him for help. He serves as an advisor to the LA Air Pollution Board. And then Beckman goes like, you go talk to these chemists at Caltech. The Caltech chemists, some of them were working actually on plants, then basically unravel the chemical origins of the smog. They say it's these nitrogen oxides and car exhaust. It's also in some of these other things, the ozone, and some stuff that's from power plants and so on and so forth. Anyway, long story, helps to unravel the kind of chemical sources of smog, and then allow LA County to start addressing the origins of the smog. So, I mean, Beckman is this interesting, but also I think characteristically Californian story in that it's connecting all of these seemingly separate stories, right? You've got, it's Caltech, and it's electronics, and it's citrus, and then it's aerospace, and it's smog, and you've got all of them kind of intersecting in this one firm and this one Caltech chemist, right? So these are the kind of networks I think that to understand California, you've really got to look, don't just look at Silicon Valley, but start to understand all of these connections. And that helps to explain, why California developed as it did.
Okay, thanks, Peter. There is the last question, Gabriela Delive. She's asking, can you recommend any material for further reading for those interested to know more?
Oh boy, it depends. It depends what you want to know more about. For aerospace, there's been some really interesting stuff written about the aerospace industry in Southern California. We've got an edited volume which touches on various aspects of this. It's called Blue Sky Metropolis, looking at the history of aerospace in Southern California from a bunch of different angles. Um, the electronics and computing in Southern California, there's not been too much written about that. Again, especially compared to Silicon Valley. There's all kinds of histories of Silicon Valley out there. There's a recent book by Margaret Amara that's called The Code, which is probably the best kind of single survey of Silicon Valley. But the problem with that is it only picks up the story really with World War II and Frederick Terman and Stanford. And I'm kind of arguing that you've really got to go back and look at some of this earlier history. So the short answer, and the other problem is that I think a lot of histories kind of tend to look at industries in isolation. So they'll look at Silicon Valley. So there's histories of Silicon Valley. There's histories of Hollywood. There's histories of the citrus industry. There's histories of the aerospace industry. But none of them try to explore these connections or spillovers among the industries. And that's kind of what led me to try to write this book. So if I kind of immodestly and also self-servingly said to recommend a single book, I would say you'll have to wait for the book that I'm working on to come out, which is really going to try to explore these connections, bring the oil industry into this, bring the agricultural industry into this, connect it all back to the gold rush. And that book, I'm just working on the last chapter or two now, so it's probably going to be another year or two before it appears. But hopefully that will be appearing on bookshelves and bookstores near you, and that would be the one comprehensive answer to your question.
Okay, thank you, Peter. So let's once again thank Peter Westwick, Professor Peter Westwick, for this wonderful talk and all the questions and answers question and answer session. Thank you, Peter. Amy?
Thank you again for having me.
Okay. Next week, June 26th, we will have a talk from Professor Demetrios Christodoulidis from UAC. Thank you.